This tutorial will start by running the pre-built genetic algorithm Java 8 University class scheduling application, and second, I will use the generated output in order to quickly explain what this application does, and third, I will step by step write and explain the code using an Eclipse IDE. This is the pre-built application. So if I go ahead and run it, and the goal is that given some course scheduling supplied data, we need to use a genetic algorithm in order to find a university class schedule with no conflicts. So here we run the application and we go from generation 0 to generation 12, where we find this class schedule with no conflicts. So this is a table format of this schedule here with a fitness of 1 and 0 conflicts. And a conflict can be one of three things for this simple application. It can be an instructor assigned to teach more than one course at the same time. It can also be a room occupied by more than one course at the same time, or it can be a course assigned to be taught in a room with a seating capacity that is smaller than the course maximum number of students. And here each population of schedules is sorted by fitness. So this is the highest fitness for this population. And if we go back to generation 0, so the fittest schedule here had a fitness of this one 0.25 and 3 conflicts. So this is the table representation of that schedule, and one of the conflicts here is that room 1 has a capacity of 25 students, and we have this class that is assigned, or this course that is assigned to be taught in it, which has a max number of students of 35. And those are the two other conflicts. Room 3 has those two classes assigned to be taught in it, so 303K and 303L, and they have a max number of students of 45. Let's take a look at another. So in generation 1, so this actually we're using elitism here, so this might be the same as this course schedule, since the first one is moved as is to the next generation, the one with the best fitness. So if we go to generation 2, and this course schedule, it has a fitness of this fitness and 2 conflicts, and here's one of the 2 conflicts. So we have Jane Doe assigned to teach this class at this time, Tuesday, Thursday from 9 to 10:30, and it's also assigned to teach this other class at the same time. So that's a conflict. And another conflict is that room 2 has this class assigned to be taught on Monday, Wednesday, Friday from 10 to 11, and also room 2 has another class assigned to be taught at the same time, Monday, Wednesday, Friday from 10 to 11. So those are the two conflicts here. And the data I supplied here is very simple. So we have three departments, a math, a EE, and a physics department. And each department, this department has just two classes, and this one has three, and this one has two. And those are the available courses. And so this one has a max number of students of 25, and those are the instructors that can teach this class. Same for this one, etc. And the available rooms are room 1, room 2, and room 3, with room 1 with a maximum seating capacity of 25, etc., 45 and 35 for room 3. And the available instructors are those 4 instructors. And the available meeting times are those 4 meeting times: Monday, Wednesday, Friday from 9 to 10, and then from 10 to 11, and then Tuesday, Thursday from 9 to 10:30, and Tuesday, Thursday from 10:30 to 12. Next, I'll start by creating a new project. And it's going to be running on Java 8. And here we will have a driver class with a main method that will be in this package. And this will be the driver for the whole application. And I will have a data class that will contain and initialize all the data. And I will have a schedule class, and a population class that represents a population of schedules, and a genetic algorithm class that evolves the population from one generation to the next using crossover, mutation, and elitism. And let me also create another package. So the domain, genetic algorithm class scheduling, and domain. And here I will have a course class representing a course to be scheduled. And an instructor class representing an instructor to teach a course, and a room class where the course will be taught, and a meeting time class representing the meeting time for various courses, and a department class where a course would belong to a department, and a class representing a course with a specific department, that is scheduled to be taught by a specific instructor in a specific meeting time and in a specific room. Now the course will have a course number and a course name and the max number of students and a list of instructors that can teach this course, and a constructor that initializes each one of those values, and get methods that returns them. So get number and get name and get instructors and get max number of students, and a toString method that returns the name of this course, and a department will have a department name and a list of courses that it offers, and a constructor that initializes those two values, and get methods for each one of them. And the instructor will have an instructor ID and an instructor name and a constructor that initializes both of them, and get methods that returns them, and a toString method that returns the name of this instructor. And the class meeting time will have a meeting time ID and time and a constructor that initializes both of them, and get methods that return them. And the room will have a room number and a seating capacity and a constructor that initializes both of them, and get methods that return them. And the schedule will have an array list of classes, and a class will have a class ID and a department and a course and an instructor and a specific meeting time and a specific room. And the constructor will initialize the department and the course and the class ID. And I will have a set methods for the instructor and the meeting time and the room, and get methods that return each one of those. And the toString method would return a string with the department name and the course number and the room number and the instructor ID and the meeting time ID. Now the data class will have an array list of rooms and one for instructors and another one for courses, and for department, and for meeting times. And we will keep track of the number of classes, and I will have get methods that returns each one of those, and an initialize method that initializes each one of those and returns this data instance. And the constructor will be calling this initialize method. Now normally this data will be coming from a database, but for the purpose of this tutorial and for simplicity we'll have it here. So we'll have here 3 rooms, 1, 2 and 3, and 4 meeting times, and 4 instructors, and 7 courses, and 3 departments, and this Java 8 code would calculate the total number of classes. Next, let's go to the schedule class. Now here we will be using data coming from the data class. So I'll have a get data method also, and we will have a constructor with data passed in. So this would initialize the data and initialize the array list of classes given the number of classes that we calculated over here. And let me define a class number counter, and I will be using this instance variable in the initialize method. And let's add an import for department over here, and an import for class also. So using the data to pick up all the departments, and picking up all the courses in each department, and for each we instantiate a new class using this class number counter, passing it in, and the department and the course. So the department and this course, and we randomly set the meeting time to one of the meeting times in data. So we're using mass.random here, and we do the same for room, we randomly set that, and the same for instructor. And then we add this new class instance to the array list of classes, and we return this schedule instance. And a schedule can have a number of conflicts, so let's define that here. And will have a get method that returns the number of conflicts, and also a schedule will have a fitness. So let's define that here, and I will also have a boolean flag is fitness changed and set it initially to true. And let me have a calculate fitness method that would calculate and return the fitness. So for now let's just return 0, and I'll have a get fitness method that checks if the is fitness changed flag is true, then it recalculates the fitness and sets the is fitness changed flag to false, and it would return the fitness. And the get classes method that would return the classes sets the is fitness changed flag to true, since we might change the classes after obtaining them. And calculate fitness would return a fitness of 1 if there is no conflicts. So we start with a number of conflicts of 0, and if the number of conflicts is 0, then we end up with 1 over 1, so that would be returning a fitness of 1. So here we are using Java 8 to go through all the classes, and for each class, if the room capacity is smaller than the max number of students for the course, then we add 1 to the number of conflicts. And we use here classes.stream, so the same as here, classes. So but we use classes.index of y is bigger or equal to classes.index of x. So we use a filter here, and then we do for each. So we check if we have the same meeting time and it's a different class instance. Then if it is the same room, then we have a conflict, so we add 1 to the number of conflicts. And if it is the same instructor, then we also have a conflict, and we add 1 to the number of conflicts. And the fitness I am returning here is 1 over the number of conflicts plus 1 as a double here. And what's left is the toString method that would return all the classes separated by a comma. And if we go to the class, each class would be returned would be this, so the department name, course number, etc. And this should do it for this class. Now going to the population class. So this is a population of schedules. So you will have an array list of schedules, and a get method that would return those schedules. And we will have a constructor with the size of the population of schedules passed in, and the data that contains all the data. And we use that data instance to pass it to the schedule when we instantiate it, to each schedule we instantiate, and then we call initialize on. And we use the size for the size of this array list of schedules when we instantiate a new instance. So here we are instantiating schedules and initializing them and adding them to the schedules array list. And we will have this method sort by fitness that sorts the schedules by fitness using Java 8 and returns this population of schedules. And this should do it for population. Next, let's go to the genetic algorithm class. And here I will be writing the code that does crossover, mutation, and elitism. And I will need the data coming in from the data class, and which will be initialized in the constructor. So we want to perform crossover for all schedules in the population. So I'll have this method crossover population, and for now let's just return null. And this method will use tournament selection in order to select two schedules to do crossover on. For now let's return null. And this method does the crossover of those two schedules that are selected here, and it would return a crossed over schedule, but for now let's just return null. And I will also have this mutate population method that will end up calling the mutate schedule method on all schedules in this population. And here for now let's also just return null. And we will have a public method evolve that ends up calling crossover population, and then what the population that's returned from that, it ends up calling mutate population on it and returning that mutated population. And before writing the code here, let me go to the driver class. And here I want to add those public static final constants. So we have the population size and the mutation rate, crossover rate, and tournament selection size that will be used by this method, select tournament population, and the number of elite schedules. Now here I will be instantiating a new population, so crossover population, given the population schedule size, this population, and the data. And I will return that new population, but before doing that I will perform elitism where I will pick up the number of elite schedules from the original population and put them as is in the new crossover population. And here we have just one elite schedule. And let's make it more visible. And for the remaining schedules in this population, and since the schedules are sorted by fitness, I will start here from the number of elite schedules. So I will start from 1 and go over all the remaining schedules in the population, and only perform crossover if crossover rate is bigger than a random number, mass.random. Otherwise, I will take the schedules as is from the original population and put them in this new crossover population. So in case we are doing crossover, then I will use select tournament population and then do a sort by fitness and do get schedules and then get the fittest schedule from those, and this would be schedule 1, and I will do the same and get the fittest schedule, and this would be schedule 2, and then I will call crossover schedule on schedule 1 and schedule 2, and set the returned schedule in the crossover population. Now here we will instantiate a new schedule passing in the data and call initialize on it, and this is the schedule that we will be returning. But before doing that, it will be populated by classes from either schedule 1 or schedule 2, depending on if mass.random is bigger than 0.5 or not. And for this method, this is population that we will be returning, and it will have this size, tournament selection size. So here it has a size of 3, and we will pass it the data and return it. But before doing that, I will pick up 3 schedules randomly from the passed in population. So we're using here a mass.random. And let me make it more visible. And for mutate population, I will instantiate this new population and return it. But before doing that, I will start by picking up the schedules. So mutate population.get schedules, and I will move the elite schedules as is from the original population to the new population. So these schedules in this population, mutate population. And I will perform mutation on all schedules other than the elite schedules. So we're starting here from the number of elite schedules, 1 meaning. And we are calling mutate schedule and setting it in this schedules. So let's go to mutate schedule. We'll instantiate this schedule and return it, but before doing that, actually we'll return this mutate schedule that was passed in. And before doing that, I will check if the mutation rate is bigger than mass.random, and in that case I will do mutate schedule, the one that we will be returning, get classes set, and I'll set to that schedule that we instantiated here. So schedule.get classes.get x should be a schedule, which would be a class in this schedule. Okay, so this will do it for this class. And next I'll be doing the driver class. Now here I will have this data as instance variable, and in main I will instantiate an instance of this class and a data instance for this data. And before doing anything, I want to add this method, the print available data, which will print out all the data that we picked up from the data class, all this data. So let me call it from here, and let's quickly test it before writing the remaining code. So here we go, this is the data that we have. Those are the 3 departments and the courses for each department, and those are the available courses. We have 7 of them, and the instructors that can teach each one of the courses, and the max number of students for each course, and those are the available rooms with the max seating capacity for each room, and those are the available instructors and the available meeting times, and this is Monday, Wednesday, Friday, and this is Tuesday, Thursday. And let me have this generation number here, and we will be starting from generation 0, and I will be printing the generation number on one line, and then on a second line I will be printing the schedule number, the classes, which would be the department. For each class I would print the department, the class, the room, and the instructor, and the meeting time. And I will also print the fitness for each schedule and the number of conflicts. So let's instantiate a genetic algorithm, passing in the data and a sorted population of schedules. So new population and sort by fitness. And I will go through all those schedules in that population, printing them, and let me define here this schedule number, and let's tab here, make it more visible. And let's quickly test run this with generation 0 before adding the remaining code. So here we go, we have generation 0 of those schedules with the fitness and the count number of conflicts for each schedule. And I want to be able to print the fittest schedule in this population as a table. So I'll have this method, and let me add this class number over here. And let's import this class, so domain.class. And I will be printing the fittest schedule here. So I do population.getSchedules.get0, which would be the fittest, and I will pass it the generation number, which we're still in generation 0. So let's test run it quickly before moving forward. So here we go. Printed this schedule in table format. It has 2 conflicts. And I will be looping over the remaining schedules in the population with a while loop, which would terminate if we find a fittest schedule in a population with a fitness of 1, which means it doesn't have any conflicts. So let's go ahead and run it. And we find a solution in 15 generations. So we went from generation 0 and so generation 0 has this is the fittest schedule with 4 conflicts. And we went to generation 14, and this schedule has no conflicts. It has a fitness of 1. This is the schedule. And let's quickly take a look at what a conflict means. So we would have a conflict if an instructor is teaching more than one class at the same time. So an example is here. Jane Doe is teaching two classes at the same time. And another form of conflict is when a room is hosting more than one class at the same time, and we have that case for this same so room 1 is hosting those two classes, 360C and 464K, and we can have a conflict when a room is hosting a class that contain more students than its seating capacity. And an example of that is also here. We have here the max number of students for this class is 35, and this room can have a maximum of 25. And here, so this one 25, and this one also, this course has a max number of students of 30, and the max room seating capacity is 25 also.